Okay, so the next thing I'm going to talk about is specific heat. Specific heat is different for each substance, and it is the amount of energy needed to raise 1 gram of whatever substance by 1 degree Celsius. The specific heat for water, liquid, so liquid water, is 4.18. Okay, and there's a formula we use here because it's the one that most of our problems are going to use. In most textbooks and in your notes, you can find a table with a whole list of specific heats for different elements and substances. And the formula that we use is pretty simple. It's a Q, which is heat, the measure of heat, and it equals the mass times our specific heat constant. In this case, water is 4.18, and it's going to be multiplied by delta T. Delta means change. So if you ever see a delta in physics or chemistry, it means it's going to be a change. And the temperature here is going to be the change from the final temperature you subtract the initial temperature, and that together is what delta T is. So if I wrote all this out, it would actually, I guess, look like this. Heat equals the mass times the heat capacity of the final temperature, subtract the initial temperature. So if you want to get rid of the delta T, if you find that a little confusing. The very first problem here says how many joules of energy are needed to change the temperature of 100 grams of water from 20 degrees Celsius to 40 degrees Celsius. And the very first thing we want to do is we want to make an inventory of everything that we have so we can figure out what we're trying to find here. It says how many joules of energy are needed. So we know that we're looking for energy, and that's Q. Q is our energy, and we don't know how much we need, but it gives us the rest of the information that we need. It tells us we have 100 grams, so our mass is 100 grams. Our C, our heat capacity, it was given to us. I put it up here too. It's 4.18. And remember, I got that off the table. You can find every substance. Some scientist has already done the math for us. And there's tables in the book, in the notes. You can Google it. There is a table for every heat capacity. You just got to find it. And it's what C represents. And then our initial temperature was 20 degrees Celsius. And our final temperature is 40 degrees Celsius. So now that we have an inventory of all the things that was given to us in this problem, we can now go through and plug them into our formula. So we don't know what Q is. Q is a mystery, so that's just going to put that there. We know that M is 100 grams. Our specific heat is 4.18, and that's because it's water. And I remember I got it off that table. That's where I got that number. It didn't just magically appear there. Our initial temperature, we put our final first, so it's final minus initial. We can go through and we can simplify this right here, get rid of our temperatures just to one number. So heat equals our mass of 100 grams times our heat capacity. 40 minus 20 is 20. We can go through now and we can just get a calculator out and solve this quick. So we have 100 grams times our heat capacity times 20, which is our change in temperature, and that tells us that Q is 8,360 joules of energy. That's how much energy is needed to change the temperature of 100 grams by 20 degrees.